today's Facades February meeting. Let me share my screen. And we'll kick it off. So welcome everyone. It's Facades February. We're going to talk a little bit about embodied carbon and facades, and we have two fantastic presenters who are going to talk to you today. Sophie Pennetier from Enclos and Isabelle Hens, who did her master's thesis work on embodied carbon at UC Berkeley, and she's now at Atelier 10. I'm going to give you, here's how it's going to go. Luke, I think, has a couple of updates to share. Then we will get into the presentation. I'm going to give a very brief intro to embodied carbon and facades, and then I'll let Sophie and Isabelle take it away. And at the end, we will do Q&A. So if you have questions during the presentation, feel free to type them in the chat, and I will ask our presenters the questions at the end. So Luke, do you have any updates before we kick off?
So the only very quick update is sharing one event with the group, which I'm pretty excited about. In March, CIOSC is going to host an all-day sustainability event. I'll share the link in the chat. It's going to be March 18th. We've got a lot of great speakers, but I'll drop this information in the chat later. Take it away.
Awesome. So I'm going to give you the 2-minute embodied carbon rundown. I assume that many people in our audience have a pretty good understanding of embodied carbon, but we'll do a real quick rundown for anyone who doesn't. So as we all have probably heard as members of the building industry, building operations account for 28% of global carbon emissions. The piece of building carbon emissions that has maybe not received as much attention until quite a bit more recently are the emissions that are associated with building materials and construction. So that you see here in the yellow portion of this pie chart, 11% for core and shell materials, and then another 10% for other materials. So altogether, buildings are responsible for almost half of carbon emissions. So that is why we are tackling this topic. When we talk about buildings, we want to talk about whole life cycle carbon, which starts long before a building is constructed and it's operating. It starts all the way at the beginning at the extraction of raw materials that are then manufactured into building components. So at each step of the way, there are carbon emissions that occur, as well as transportation to the building site, construction, and then deconstruction or demolition at the end of the building's life, and disposal. So we're trying to think more holistically about the whole life cycle carbon of buildings, and that means starting to focus more on the embodied carbon. And everything in yellow in this chart is considered part of embodied carbon. So another important concept here is the time value of carbon. Embodied carbon can also be called upfront carbon. So these emissions happen right now while new buildings are being constructed. So if we're going to meet our near-term 2030 emission reduction goals, we really need to start looking at the emissions that are happening now at the very beginning of our building's lifespan. Finally, we're going to talk about facade materials today. So this cool little graphic is the embodied carbon materials pyramid. It's kind of like the food pyramid in that the things at the top of the pyramid are more carbon intensive and are things you want to think really carefully about before you use them. So you'll see I've circled in red a bunch of common facade materials like aluminum, insulation, and glass. So these are materials that we really need to target for embodied carbon reductions. In addition, when we're talking about facades, we're not just talking about individual materials, we're talking about systems. Each material within a facade is performing a different function, and you need them all working together to get a facade system that works, and each of them is going to have different carbon intensities. So when we think about facades, we don't want to just think about materials, we want to think about the whole system. There are a lot of great resources out there on embodied carbon and facades. Facades Tectonics Institute had their August, September Skins newsletter last year focused on the carbon crisis. The Boston Society of Architects has done an Embodied Carbon 101 series, and they have a session focused on envelope. And I and some of my colleagues have written some articles about embodied carbon and enclosures for various publications. So we're going to share some of those links in the chat. The other one that's really cool is a tool called Kaleidoscope that was made by Payat Architects that actually lets you look at some different facade assemblies and how they stack up against each other in terms of embodied carbon. So I think Luke is going to share links to a bunch of those things in the chat, so you guys can check them out if you want to learn more. And with that, I'm going to turn it over to our presenters.
Hello, everyone. I'm Isabelle, and I'm really excited to be here today to present about my research on embodied carbon of timber unitized curtain wall. So I did this research while I was in the Master of Science in Building Science, Technology, and Sustainability at UC Berkeley. And I'm now an environmental designer at Atelier 10 in San Francisco. And for this research, I had the privilege to work with Sophie Pennetier, who will present later, and also Simon Schleicher, who is an associate professor at the Department of Architecture at the University of California in Berkeley. And so the goal of the project was really to look at what is the comparison of the embodied carbon of timber unitized curtain wall instead of using the typical aluminum mullions in unitized curtain wall. So why do we want to focus on curtain wall in the first place? Well, the building envelope as a whole plays an important role in operational building performance as it mediates between the interior and the exterior environment. And in addition, it can also significantly impact the embodied carbon because of recurring contributions, because envelopes are often replaced more frequently than the structure of the building, both because of building renovations to improve building performance and because they simply have a shorter service life than the building structure, for example. And then curtain wall in modern architecture is a popular system for cladding building envelopes. And because of its prevalence, curtain wall could play an important role in reducing life cycle building impacts and impacts of the built environment as a whole. So why do we want to look at unitized systems as opposed to stick-built systems? Well, in the context of sustainability, unitized systems can have an advantage because they're more durable thanks to the tight precision that can be achieved in a factory environment. And in addition, prefabrication of envelope systems particularly has an advantage in the context of mass timber structures. Currently, CLT structures can be constructed really fast, faster than stick-built enclosures, which means that the erected CLT structure currently often is not immediately covered by an enclosure, and therefore all types of additional weather protection has to be set in place. So this problem could potentially be addressed by a higher degree of prefabrication of envelope elements. And then finally, why do we want to focus on timber? Timber has some potential advantages over aluminum or steel, including the fact that it's a renewable resource, it's low thermal conductivity, and then it's low embodied carbon. So our project aims to quantify the environmental impacts of a timber unitized curtain wall system in comparison to an aluminum system in terms of global warming potential, so embodied carbon, for two geographical scenarios. We looked at the East Coast of the US and the West Coast of the US and project sites in cities in both of those locations. And then currently the availability of timber unitized curtain wall products on the market is really limited. So for this part of the study, we focused on a hypothetical timber system based on some preliminary calculations of how much timber and what type of system is needed to create an equivalent system to the typical aluminum systems that are used right now. And the goal was really to quantify the global warming potential of the major components of that system ahead of developments of timber systems in the future. And so this diagram shows the different life cycle stages of a building, and our project, or the part that I'm going to present now, focuses on the production stages. So that's A1, A2, and A3, and then the transportation component of the construction stage. So that's transportation to the building site. And then to be able to compare the two systems, we made a set of assumptions. Each curtain wall unit is 5 feet by 13 feet, of which 3 feet is spandrel, consisting of double glazing and insulation. And then 10 feet is vision glass, consisting of double glazing. Then the aluminum system, as you can see on the left, has an extruded aluminum frame with a 3 by 7.5 inch composite aluminum mullion, while then the timber system on the right on this slide has a glulam frame consisting of a 3 by 10 inch non-composite mullion of timber halves, and also an aluminum adapter that is structurally glazed to the back of the IGU. And so, as I said earlier, we compared an East Coast scenario with a site location in New York City to a West Coast scenario with a site location in San Francisco. And on each of the maps that I'm going to show next, the transportation for installation is shown on yellow, as the legend in the bottom left shows. The transportation for glazing is shown in teal, for aluminum in gray, and then for timber in orange. And the numbers on the map represent the order of decisions. So first, we determine the site location of a project. Then we choose the curtain wall factory closest to that site location. Then we see which port in the US is closest to that curtain wall factory to ship any international materials. And then we also look at the factories for the individual materials, and if applicable, the nearest port abroad. So the port in the other country where the materials are shipped from. Then the emission factors for transportation by ship and truck that you can see at the bottom of this diagram were based on the Walter P. Moore Stewardship Report on Embodied Carbon. And then for each scenario, we considered 3 possible factory locations for just the double glazing units, so shown in this teal color. We looked at Minneapolis, Plättling in Germany, and Tianjin in China to look also at the sensitivity of the global warming potential to where the glass is coming from. So this map shows the East Coast scenario. We have our site in New York City. The curtain wall factory for this scenario is in Chester, and the US port is in Norfolk. And then the insulation factory is in Fort Wayne. The extruded aluminum factory is in Albany, and the glulam factory is in Quebec. So all as close as possible to this project site. And for the West Coast scenario, we have a site in San Francisco. The curtain wall factory that we considered that was closest to this location was in Phoenix, the US port in Oakland, the insulation factory in Fort Wayne, the extruded aluminum factory in Los Angeles, and then the glulam factory is in Vancouver. And then this graph shows the global warming potential in kilograms of CO2 per square foot of envelope area for the aluminum system on the left and the timber system on the right for just a production stage, so A1 through A3. And we can see here that the timber system has a global warming potential that is 24% smaller than the global warming potential of the aluminum system, which is pretty significant. And interestingly, aluminum is still the second largest contributor to the global warming potential of the timber system. And that was that aluminum adapter that I pointed out on the drawings earlier. So this graph kind of further illustrates that. So we have the aluminum system on the left side, the timber system on the right side. And on the inside of these graphs, we see the contributions of the different materials by mass in the percentages that they contribute. And then the outer ring of the graph shows the contributions of the different materials to the global warming potential. And so when we look at the right graph, the timber system, we see that the aluminum only comprises 7.4% of the total mass. So it's a really small part physically of the system, but it contributes 28% to the system global warming potential. So a really disproportionate contribution there. And then this graph shows the global warming potential values for the transportation component of the construction stage. So this is the transportation from all of the individual manufacturers to finally the project site. And again, we have the aluminum system on the left side, the timber system on the right side. And then within each of those systems, we have our East Coast scenario and our West Coast scenario. So we see that, oh, and also then there's another distinction within each scenario, which is a double glazing manufacturer in the US, in Germany, and in China. So those are the ones that I pointed out on the map. So we see that here the global warming potential values of timber are actually slightly higher than for aluminum. So in terms of transportation, timber could be made more competitive if it can be sourced more more closely to the curtain wall factory. And for both materials, we see that the West Coast values are much worse than the East Coast values, which is partly because the closest curtain wall factory to San Francisco that we considered was located in Phoenix. Then this graph shows the overall global warming potential for stages A1 through A4. So that's adding up the first graph I showed and the second one. And as shown by the horizontal lines, the production global warming potential in this study is taken constant across the scenarios within each system. And this is because there's often a lack of location-specific environmental product declarations. So for example, there's not always an EPD available for glass manufactured in China. So for the purpose of this study, we kept that constant. And that also makes it easier to distinguish the contributions of the transportation. And so on this graph, we see that while the West Coast scenario still performs slightly worse than the East Coast scenario, the values for timber are now lower than those for aluminum. So in other words, while aluminum performs better in terms of transportation, the better performance of timber in the first three production stages has sufficiently more weight to make timber the best performer overall for stages A1 through A4. And then we can make some individual comparisons within this graph. So in relation to the aluminum baseline, so comparing all of the aluminum scenarios with all of the timber scenarios, we see that a timber system can result in a 10 to 17% reduction in global warming potential, depending on the project site location and also the glass manufacturer location. So the material selection here really makes a big difference in the embodied carbon. Then within the timber system, we can also compare the West Coast scenario and the East Coast scenario. And here we see that for the considered supply chain, a project on the East Coast has a global warming potential that is 8 to 19% lower than a similar project on the West Coast. So this really shows that different project sites benefit differently from the global supply chain. And then finally, choosing a local glass manufacturer also really matters. On the East Coast, a manufacturer in Germany or in the US results in a global warming potential of 7 to 9% less than if the manufacturing in China. And on the West Coast, because of the transportation routes, glass from Europe actually results in the largest global warming potential. So to conclude, to reduce the consumption of raw materials and energy, the building industry needs to reduce its life cycle environmental impacts. And the building envelope can contribute significantly to both operational and embodied emissions. So this study that I performed together with Sophie at Enclos shows that using timber instead of aluminum in unitized curtain wall can help reduce the embodied carbon associated with production and construction, especially if local manufacturers are considered. So designers in this case can have a significant positive impact on building emissions by selecting materials and systems in a mindful way. And curtain wall manufacturers can play an important role in selecting the manufacturers that they work with and choosing their supply chains conscious of emission impacts. So I will then hand it over to Sophie, who will talk a little bit more about all the interesting details of supply chains and how we can integrate all of these considerations from the beginning of the process.
Thanks, Isabelle. Let me share my screen. Can you see my screen? Yep. So Isabelle showed you the research that we did together last year on the curtain wall that Enclos as a curtain wall manufacturer is envisioning. We looked at some very standard profiles and how, you know, the integration of timber could make sense for our industry that has been driven by, you know, factors such as cost, schedules, things that have driven decisions, but now, you know, now that we need to be encompassing altogether more mindful designs, they might not be in every single case the best solution. So we're very grateful that we were able to have Isabelle assist us with those findings. And so I'll talk about the point of view of a manufacturer in the design, and if I, yeah, in design and choices of materials and our suppliers. And I just want to start this presentation on embodied carbon saying it's just not just embodied carbon, and there's a lot beyond that needs to always be reflected upon when we choose lower carbon material. And there's a lot of resources here on the screen that help us keep those in mind as we are optimizing for lower carbon solution. So Laura showed, and Isabelle showed us that currently the facade industry is using the most emissive materials, and this is where we stand. And taking action is just not just, you know, all the ladies around this table here trying together to change and things. It's a real there are landmark cases around the world that are really, you know, it's not just tree huggers now. It's becoming, you know, matters of extreme seriousness, and there's a really good reaction from the industry to invest in the right direction. And so around the world, you know, cases related to other industries, but for our industry, we see around the world and also in the US some action that is going towards lowering embodied carbon for especially here on the left side in public buildings. Another regulatory step here in California is the Buy Clean California Act, which caps the emissions of the materials for public projects to those limit brought up on the screen. And we shared those slides in the previous presentation, and I already needed to update them since November. They were issued, or I guess targeted around a bump above the average of the industry, and now they're at the average of the industry, which means we are really seeing this kind of goal of capping, but also increasingly reducing the embodied carbon of the materials we use. Aluminum is not in this list. So what I was talking about this gradual reduction, and that is an old slide where we used to have a 1.72 ton per ton of glass in the previous version of the Buy Clean California Act. It used again to be a 20% bump above the average, and now it's at 1.43, which is the average. And there's this understanding that these things are going to be, decreasing throughout the years at a pace that is unknown yet. But a good sign is that our glass suppliers are already taking action in reducing the emissivity of a lot of the most emissive production steps. On the left side is, again, this typical graph you see in every PD. For those who have opened PDs, never forget that there's the global warming potential, but other factors that need always to be taken in the back of your mind. So as I was saying, lots of our suppliers around the world are already taking action. So for instance, Saint-Gobain is starting to increase the amount of cullet in their mix. And I have this smile here because I remember having being laughed at a couple of years ago. Yeah, this is great. This is happening, and I'm so glad to see Saint-Gobain, Gordian, and all sorts of suppliers, major suppliers, taking action again into reducing their manufacturing steps. So that's a great start. Aluminum is also investing significantly into reducing the emissivity of those fabrication steps, the smelting particularly. And for those who have not seen it, there was this amazing presentation this morning by the AIA. I hope it'll be put in a chat from the Aluminum Extruder Council that is giving an update on the progress of that group towards decarbonizing the aluminum extrusion. So that's great. We see that coming. So every subpart is decreasing, and we as a manufacturer have to chase those ones and offer them as option to pick for our clients. We need to also have design assist that is carbon informed. When we talk about light and all sorts of things during design, I'm talking specifically about a recent project. We need to keep in mind the impact of every design, every solution, not just in schedule but all those aspects we just mentioned. And so we have collective decisions path. We need to finalize the life cycle assessments early on before we're tied into shop drawing seminars. So things that you can look up at, and that's some of our conversations with, again, people we have here around the table. Looking at the finishes are often drivers of where you're going to extrude your mullions, basically. Look at anodized versus painted for potential for recyclability. We heard this morning from the, again, Aluminum Extruder Council that maybe anodized might have a better potential for recycling. That's something to be further developed. I'm just quoting the AIA session from this morning. Look at size of your dies. Funnily, again, just a few years back, all your bigger dies, 12, 16, you had them only overseas. Well, guess what? In LA, this month, or plus or minus one, Hydro is pushing its 12-inch press to just max up what you can procure locally. So that's really great news. Meaning what, all the parameters that we use for our design and our supplier selections are constantly changing, as we all know, and it's something to keep in mind and keep abreast. And that's for aluminum. And then for glass, Isabelle touched on this. Try to select things that can be, floated locally. There are some horror stories in the industry that all of you all have heard of, things coated someplace, fritted in another place, manufactured into an IGU and into another place, going around the world to a curtain wall supplier, and then shipped to site. So those horror stories are driven by a lack of awareness from all the stakeholders around the table of the impact of their decisions, even when it's just a little frit, thing. And so ask questions, and there's lots of things that we all learn throughout the process. And then the lower portion of the slides here is, this timber system that Isabelle has studied stem out of our own research, and it was difficult to find local timber suppliers for the very specific elements we needed. And so a lot of, and also during the COVID times, like supply chain disturbance and, you know, a project that has to be built and delivered, had led some conversation towards buying timber from Europe. And so, you know, this is always something to be kept in mind. What are the implications of taking those things from overseas? And it might make sense in certain times and sometimes not. And so we shouldn't be, you know, poo-pooing and favoring, you know, one material or another until we know the full story. And this story is going to, again, keep on refining itself. We'll get more and more detail as we learn more. And obviously, let's make sure we go towards timber, if we go towards timber, towards sustainable practices, of course. And so one thing I really would love to see, and people still think I'm crazy, but let's just propose this, is holistic bidding. Like it's not just, you know, a matter of having a price matrix and a set of specifications. I wish to see more integrated comparison and matrices. And so maybe that's something I don't see on my side as a manufacturer, and all the magic is happening behind the curtains. I've seen though, and it very likely was in this CLF presentation, some holistic bidding on concrete, but I've not seen this in facades world. So let's transpose this great thinking. There was this table presented by MKA at one of those presentations. I cannot tell you whether it was using a real project. I wish they can reach out to me. I'd love to talk to them about this. But the concept is simple, having a comparison between various items in the building downward, and then different type of, you know, you choose what you need, where you need it. That's also another wise way to size components. We could even talk about this for glass and thicknesses, this kind of things. So that's downward. And then as we go towards the right, we start to see comparison in those various components in their proposed baseline and various alternate lower carbon. And so I'm proposing to bring this to the next level for facades, not only just looking through different wall types and their various quantities, but also looking at and the various quantities and embodied carbon and environmental impact, but also how they compare in terms of lead time. Like, what does that mean that you need something for tomorrow on Amazon Prime shipped to your door? What does that mean when you can line up in a backlog of a local supplier that has sustainable practices? And how do we bring that mindfulness in our industry? I know that it's different from buying on Amazon, but I wish to see this kind of philosophy seep through into bidding processes. And another thing I have here on the screen is like, let's free our brain to resolve the climate crisis, and let's make things easier for everyone. There's lots of great tools that exist, and I'm shocked that it's still not as leveraged enough in our bidding process. And you know, Enclos bids on the biggest, you know, projects and towers that have significant, or campuses of the biggest tech companies. They have significant resources. There's lots of Revit, you know, framework. We have the top notch of the technology. However, those things completely drop when we turn into the bidding process. And I'm wishing to see this more leveraged during the bidding process. Give me some Revit that are already filled so that I can go in there, you know, use the schedule and just not, you know, bang my head on the wall trying to understand what were they thinking. So when things are live, when things are pre-populated, it's the best way to track components down and spend all the focus, all our brain power towards finding creative solutions in order to have better supply chains. So, all right, that's it. That's the end of the moment. I'll move on into bringing some creative solutions for end of life, and I'll try to wrap up in 5 minutes. I don't like the word end of life. You know, it's an end when the thing disappears and goes into the landfill. It doesn't disappear. So Hopefully extension of life and more circularity is something that we can integrate in the way we design and draw the systems. And so when we choose a material today, how is it going to impact the next cycles of buildings this is going to be installed on? Like, have the other industries figure it out? Is, you know, the 100% recycled aluminum from this foam company made from 100% foam in the first place, or does that come from 20 foams? How can we, you know, respond to the need of changing the look of things? Because it seems that a lot of those, you know, drivers sometimes for retrofit are needing to change the, you know, giving a facelift to this old beautiful building. So maybe using toggles and modularities helps to just change a part of the building, a part of the facade. You know, design for disassembly significantly for us changes the install sequence, the install tooling, the time we're going to spend on site, the labor. However, maybe it's a cost that we're all willing to just spend in terms of hours in order to make our facades last more longer. And what is this is not the case today. And so hopefully we can think beyond this. And then there's also been conversation about take back programs. Somebody in this presentation just disturbed me. So we at Enclos have started to look into what it means to disassemble our own units. This comes from an acoustic mockup, and so we've looked into various tooling, various orientations, just to create some process in order to design for disassembly. And I think every party should be involved in this, not just for like deglazing, but also taking apart the aluminum. And you could imagine that I know some foam industry folks have this for disassembly, but you could see how at larger scale, when you have like an automated line, you could just rewind the video and have a, you know, disassembly line becoming a disassembly line. That's my dream, at least. Improving aluminum circularity. There's lots of contamination in all the sealants and some paints, and various fasteners that get stuck in the mix. And so having the dialogue about, you know, how to change maybe this waterproofing strategy in order to make it more recyclable, for instance. And is the goal to remelt and you know, aluminum and glass, or is it just to have processes again and method that allow a clean you know, removal of the parts and moving them from one place to another? A couple of years ago, again, at the same time, people were laughing at increased recycling content in architectural glass. They were also laughing at circularity of laminated architectural glass. There was this fantastic report from Europe on the circularity of glass just a couple of years back, 3 or 4, if I'm not mistaken, you know, that was explaining the challenges of recycling laminated glass. Well, no more. So again, like I was at the time like thinking, oh, how do I design, you know, for like captured system that prevents the use of laminated glass? You know, safety glass can be something else depending on the region in the world where you are. And so no, technology also improves, and it's great. We have to have faith in that improvement. And so we have brought our own glass in a recycling facility where we're able to separate PVB that is going into a full architectural circular PVB chain. And the glass itself can be brought into currently fiberglass insulation, but hopefully that's the one that will go one day in the float line. And I think we're living at the same time extremely depressing and extremely exciting times. It's a time that, you know, all those materials that were here when we joined this industry, I'm saying, you know, a decade ago or maybe 2 for certain designers here, the materials already were in place and chosen. Well, why don't we today look into materials that serve further purpose? Maybe, for instance, you know, you cannot use timber in many instances and situations, but what if you start reinforcing? What will you take the both advantages of a a weaker but better carbon material and a stronger material, etc. And so same for interlayers, same for insulation. And so there's a lot of good things that can come from this exploration. And so in closing, here is my like little board. Like what is, ask yourself, what's an actual cradle to cradle facade? Go onto YouTube, lots of nerding videos out there to kind of understand how things are made, and it can give you ideas. Enclos has a Vimeo channel where you can see how a curtain wall is made. And and don't forget about my request to make bids more holistic. In second closing, the quote that I think of every morning when I get up is from the Cradle to Cradle. Negligence starts tomorrow. Let's not be angry about the fact that the materials we've been using have been optimized for other things until now, and things need to shift, and let's educate ourselves, measure it, and start small, but start. So with this, that's the end of my presentation, and I'm sure we'll have some questions.
Thank you, Sophie and Isabelle. I have seen this presentation before, and it makes me like so excited and inspired. So we can take questions either in the chat, or feel free to unmute yourself, and if you'd like, turn on your camera and just ask a question. I did see one earlier in the chat about using timber, which is a combustible material in type 1 buildings. And I think, Isabelle, you shared a link to a paper about that topic. I don't know if anyone has anything further to add on that one.
Yeah, definitely look at that paper if you're interested in the details. And just in general, I would add, I think for mass timber, we've made such progress between 2008, where we had a 10-story timber building, versus now where we have an 18-story timber building, and firms are making visions for 80-story timber buildings. And so we're really pushing code there and showing how well mass timber can actually perform. So I hope we can do the same thing for timber as an enclosure material.
Yeah, there's still a lot of fire-related issues with using timber. That's the one that we're, Isabelle knows a bit more than what is shown here in the slides, but this is the one problem we're having right now, dealing with you know, the fire going through our spandrels and making sure there's some viability there. So it takes a lot of testing. That's certainly the next challenge for the timber as facade median for unitized curtain wall.
Thanks, guys. And I also added to the chat earlier a link to the webinar that Sophie mentioned about aluminum and the environmental impacts of aluminum. It unfortunately happened earlier today, but I'm hoping they'll post a recording. So I'm keeping an eye out for that recording. And if it's posted, I'll definitely share it in the CLF LA Slack. I saw Anthony also shared a link to the CLF has a resource that's kind of explaining the Buy Clean California Act and like how it works and how to comply with it and all that. And it's a really great resource. So definitely check that one out too. Any other questions from the audience?
I even have my little hand up.
Oh, Jill, sorry. I was looking for hands.
I know, it's sort of new and exciting, right? This question is to Sophie. Did I understand correctly that glass can be ground down and recycled? I'd understood that the coatings that we now cover our glass with for operational performance makes that proposition much more challenging.
Yeah, so I don't pretend I'm going to be the specialist here, but I'll share with you what I know. The coating is not a problem for using the glass towards fiberglass insulation. So that's the loop we tried with a recycling partner. For them, there was zero problem in reusing it for, believe it or not, see, that's the thing I should have Googled on, you know, or looked on YouTube before. To do fiberglass insulation, people float glass and then break it and make this kind of candy, sugar candy threads to make, I had no idea. And so at least for that purpose, there's no problem. I know there was a problem for architectural glass. So I don't know exactly where that stands. Whether the increased cullets that the float lines are using, like where that comes from, I do not know. And so that's certainly a question that we'll ask very soon. Isabelle, Laura, and myself are going to go interview a local glass supplier. We'll hear more then.
Yeah, I had heard kind of both ways on the coding thing, Jill, because I had heard the same thing as you, that coated glass isn't recyclable. I think the ARIF report that Sophie referenced about circularity of glass had said that actually it is, although they didn't specify like what it's getting recycled into. So I think we're still looking at like a downcycling situation. But we'll have to continue doing the research and pestering the glass suppliers.
And things change. This anonymous person keep from this conversation here and around this table keep messaging me, but telling me there's no problem. You know, 2 years ago we talked to aluminum, like the biggest aluminum extruders here in the US, and they were telling us that paint used to be a huge problem for recyclability. And so it seems as though technology seems to shift and different people see things differently. So I can tell you that there's contradicting positions right now, but these things are changing. And so today, all of those that went into the AIA session heard that paint was no longer a problem for recyclability of aluminum, and it used to be a huge problem. So yeah, sorry, I hope it brings a bit of hope into that conversation. Also, keep in mind the difference between automotive glass and architectural glass. There's this apparently clarity requirements are slightly different for optical glass and architectural glass. And so I wonder, and I cannot, you know, I'm not a specialist here. I wonder if that's where the divergence might come from.
Awesome. I think Kathleen had a question, and then Colette after Kathleen.
Hi all, thank you for the wonderful presentation. I would love to hear more about holistic bidding. I think a lot of us have been just praying for something like this to happen to the industry, and it's really exciting. I would just love to hear more about what people have seen, where they think it's going, how soon do you think they could become more commonplace. Just very, very, very excited. So thank you for sharing. Great presentation. Yay.
If only certain consultants wanted to make this type of bidding.
Laughs maniacally in the background.
No, but it's great. We're already having to provide EPDs. That's something new, and things are shifting slowly. So hopefully that's the next step we all take together.
Awesome. Colette?
Hi, I wanted to thank this group for hosting this event. This is my first time joining one of your events, found you through LinkedIn. Joining you from Canada, as is my colleague Veronica, who popped into the chat. We've been fortunate enough to be involved in what at the time was the first large 14-story timber frame construction project. And at the time, they knew that they wanted the facade of the building to look also like wood, but getting a sustainable wood product seemed quite difficult, as well as non-combustible. So there are HPL products, high pressure laminates or compact laminates, that have 70% wood fiber. And now we will also be representing a panel product that is carbon neutral. And that works really well on a facade when people are looking for solid cladding areas, not for your opaque glass walls. And just wanted to bring that to your attention, that there are a lot of people on the facade side as well working for sustainable materials that are going on facades as part of timber frame, and understanding some of the challenges with fire code regarding all of that. So we did that one in British Columbia, and then closer to my office in Toronto, we're doing another one, which is going to be the largest academic building in Canada. It's called Centennial College. And it just had its topping off ceremony today, and we're waiting to deliver panels in the next couple of weeks for that one. So just wanted to share that.
That's awesome.
So exciting.
Oh, and I guess I was going to ask, would you consider holistic what I call a P3 or a public-private partnership, where really the interested parties get together and the cost analysis is done upfront and everyone is an invested stakeholder in the project? It sounds a bit similar to holistic, but I'm wondering if holistic is different than a P3.
Well, it doesn't exclude of one another. I guess P3 can be holistic too. We, at least from Enclos standpoint, this is not, we do some P3, but you know, I don't know the right ratio, but this is not the majority of product we do, and certainly our, you know, environmental impact. Yeah, let's have this practice everywhere. At the contrary, totally up for it.
Okay, thanks.
Looks like Chikara has a question.
Hi everyone, and hi Sophie, let's see you again. First of all, thank you so much for these amazing presentations. I mean, you know, every time I hear Sophie speak, that, you know, I get really excited that, you know, I think she has that power. I think along the line of these holistic biddings, I have two questions. That one is, I'm currently working at this local firm called Core Architects here in Los Angeles. I serve as the director of digital technology here, and we are beginning to see an excitement and an interest in this sort of energy simulations, slightly less on the sort of carbon footprint just yet, but then from engineers and manufacturers' point of view, how, I guess I'm seeking for an advice here that how do you see sort of excitement that's happening on your end and bringing that to the sort of very beginning of a design practice? How do we sort of get everyone on the same page so that we can really sort of try to push this forward? And then I guess the second question is that now that we have an ability to simulate on the sort of energy daylight side of things, as well as manufacturing and carbon footprints all the way from transportation to recycling, what is the sort of best way to look at these sort of two spectrum together?
Yeah, that echoes some conversation we had with Laura the other day. Manufacture, and I don't want to speak on behalf of Enclos. I just want to share my experience as being a consultant for 10 years and then what I learned from moving to the manufacturing side. And my opinion, anything I share here is just my own opinion. But we were talking about how at early stage manufacturers give feedback already before the bidding process, give some hints to the designer, you know, like, here's an idea of how to rationalize a facade. Here are some cost drivers that sound, you know, little to you maybe because the material is the same, but the labor is going to be different. And so that exists already from a manufacturing standpoint. And I hope it keeps, it continues with carbon as well. For instance, maybe, you know, we can all share, you know, where we think things are going, or who is busy in the world for, I don't know, production of glass, or the current crisis in Ukraine and what it means for the European glass, and etc. And so hopefully we share some general news at early stage. And you talked about long-term as well. What is our role as, you know, it's more like a citizen thing, like how do we think of like those beyond cycles is definitely a philosophical problem. I see Laura and you know, and Luc nod, like, you know, they have the same problem when we talk about adaptive reuse of buildings and these kind of things. Like, how do we see the beyond loops? I can only tell you that we just need to keep these conversations going. And all the things I had learned, I mean, I learned so much on carbon through listening to those conversations here, the CLF and the forums, and that's a great source of information. Sorry, I didn't want to take the mic away from you all.
Thank you guys. Thank you, Isabelle and Sophie, for presenting, and thanks everyone for your questions and insights and all the great links that are in the chat. We will be posting a recording of the presentations on the CLF LA website, and hopefully also sharing some of the great links that were put in the chat. So yeah, just wanted to thank our presenters and thank everybody for coming. And if anyone wants to hang out and chat, you're more than welcome to hang out on the Zoom and chat, but this concludes the formal portion of the event.
Thank you so much for having us.
Thank you, CLF, for existing.
Do we unmute and give a little clap?
Yeah,
There's a lot of
let's do
thank
it.
yous in the chat. Great presentation. Thanks so much for taking the time.